Alright, hello once again, Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Language Fundamentals course, I have been going through a series of video presentations I'm creating for the textbook for the class, which as you can see here is Muroc C# 2015. Right now I have gone through all of Section 1, the 3 chapters in Intro to Visual Studio, all of Section 2, the C# Language Essentials, and in Chapter 3 I've gone through 12, 13, and 14, which, as you'd guess, well, I'm not done with 14. I should say that. I got to finish 14 up. I've been the home stretch, so to speak, of inheritance, rather. So, I left off right here talking about the type class. Now, one of the things that was mentioned earlier that we get from the system.object class is a getType method. You can use getType to get a type object that represents the type of the .NET object. Some of the members of the type class are shown here. So we've got name, returns a string that contains the name of the type, full name, which is the fully qualified name, including the namespace, etc. Base type, which represents the class that a type inherits. Namespace, which contains the namespace that contains the type. And getType, sorry about that, which returns a type object that represents the type of an object. All right. Every object has a getType method that returns a type object. That type object corresponds to the object's type. You can use these properties to obtain additional information. All right. The easiest way to test an object's type is to compare the type object that's returned by getType with the type object that's returned by the typeOf operator. And yet another way to test an object's type is to compare the name of the object's type with the name that's returned by the nameOf operator of a type. Okay? So we've got an example here, code that uses a type object that runs through some of that stuff. So notice name gives you book because that's the name of the class. Namespace, that'll give you product maintenance because that's where the namespace is. So the full name is the namespace dot the class name. And product maintenance is of type product. All right, just mention this, a couple different ways of testing. All right. Another confusing aspect of using this is knowing when to cast types. All right. C# can implicitly cast a subclass to its base class. What that means is you can use a subclass whenever a reference to the base class is called for. For example, you can specify a book object whenever a product object is expected because a book is a subclass of product. However, you must explicitly cast a base class object when a reference to one of its subclasses is required. In other words, you must explicitly cast a product object to a book if a book object is expected. If you attempt to cast a base class object to a subclass, you're going to get an exception, in particular, an invalid cast exception. You can use the as operator to cast an object to another type without throwing a casting exception if the cast is invalid. It simply returns null if indeed that is going to be invalid. All right? And there's an example of that. There's a cast exception. All right? You're trying to take a software and cast it as a book. But if you do that with as, you'll get null, but you won't get an error. All right? All right, next we've got talk about an abstract class, and we will also talk about a sealed class. Now, an abstract class is one that cannot be instantiated. it is so broad or general. It's like if you said to somebody, you came to work today and you've got a big smile on your face, and your coworker says, "Hey Jeff, why are you so happy?" You say, I bought a pet." Well, they're not going to think a pet. They're going to say, "Well, what did you get?" Because a pet is too broad. And you say, "Well, I got a dog." Well, what kind of dog? "I got a German Shepherd." Well, now I'm drilling down. It's just kind of the same way I'm seeing all these commercials on TV for Capital One and how you can go in there and open up accounts, etc. If I walk into a Capital one of these stores, and I say, "Hi, I'd like to open up a bank account," the first thing the teller is probably going to ask me, is that a savings account or a checking account? If it's a checking account, what kind of checking account, etc. So if I said account, if all bank accounts have something in common, this abstract would be account. So every single type of bank account would have this stuff. Notice that when you do this and you make it abstract, you can set up data members, but when you set up methods, you do not put a body in there. Rather, the type, the fact that it's abstract, what it returns, its name, and any parameters. All right. Now, when you do this, anyone that inherits from this abstract class must provide a getDisplayText method. It must take in a string and return a string. All right. Abstracts can have read-only properties. Notice there's just a get there. And here, product, this inherits from product. So it must override that getDisplayText. Again, it must pass in a string and return a string. All right. Next, we talk about sealed classes. In contrast to an abstract class that must be inherited, a sealed class is a class that cannot be inherited. Some books that I've read refer to this as like a leaf node class. All right, it's at the bottom level. You can't not inherit from it. So a sealed class is a class that can't be inherited. To create a sealed class, you code the sealed keyword in the class description, like that. Sealing a class can result in a minor performance improvement because the compiler doesn't have to allow for inheritance and polymorphism. But the problem with that is what you're basically saying with that is, hey, I know so much about this that this class is so good that you'll never want to inherit from it. So it would be illegal to have the public class, the name of a class, :book. Okay? You can seal classes. All right. And it's fairly complex. Again, as we're getting into this, I'm more concerned that you understand what we're talking about. All right? And not so much that you understand every little intricacy of what we're talking about, but that you're basically able to go in and say, oh, okay, I understand. I could set myself up something similar to the product type of thing that we just looked at. All right. So that brings us to the end of yet another chapter. So next I'm going to go into Chapter 15, which is how to work with interfaces and generics. We've got this chapter, and then we have Chapter 16. Which is on how to organize and document classes. It's a very short chapter. So we're going to hit those next, and then we'll be done with Section 3 of the book. Back with more in just a little bit.